Okay, Assalamu alaikum. Now we'll consider now the second point in section 4.1. Okay, so let me 14.1 afwan. So let me just make share. Okay, so it is about level curves and level surfaces. Okay, the point is easy, but maybe the terminology makes it a little bit hard, but it is not really. Okay, so I will do this in two stages. Okay, just first I will give the definition, and then I will give an example. Then I will make a clarification of the definition. So for now, just try to read the definition and apply it, and then we'll give its real meaning. Okay. So we have level curves and level surfaces. Definition: the level curves of a function, of two variables, z equals f of xy, are the curves in the domain of f, whose equations are given by f of xy equals c, where c is a constant in the range of f. Okay. So notice I replace it, the definition replaces z with c, a constant. Replace z with c. This is a curve in the domain of f. It is called the level curves of f. Okay. Well, just for now, just try to apply it, and then we'll explain it further later. Just let me just apply this definition as it is given. Okay. So here, example here. Describe the level curves of a function of two variables. You need to describe this. Okay. How to find or describe the level curves of a function of two variables. I will apply the definition. The level curves are the curves in the domain whose equations are given by f of xy equals c. So just replace z with any constant. So I will say that by the definition directly I have the following. The level curves are given by f of xy equals a constant. See, a constant. So this implies, what is f? It is y minus x squared equals c, and hence y equals x squared plus c. Okay. So the level curves are the curves given by this equation. What are these? Okay, these are parabolas. Okay, and they are curves in the domain of the function. The domain will be in the xy plane, and they are parabolas. Okay, for different c. You can choose different values of c to see what happened. Okay, so this is the domain in the xy plane here. So this is the domain in the xy plane, x and y. Okay. If I take c equal to 0, I get y equals x squared. So this is the curve here, y equals x squared. So this is c equal to 0. It is y equals x squared. Okay. If I take c equals 1, I get this parabola here. Okay, so this is the parabola here. This is 1, and this is h. Let me call it c. C equals 1, y equals x squared plus 1. If I take c equals minus 1, I get h, the second parabola here. So this is the second parabola. Okay. That is c equals minus 1. And this is y equals x squared minus 1. Okay. So these are some level curves. They are curves in the domain of f. Okay. They are curves in the domain of f. Okay, so what is the property of this curve? What is the property of this curve, of these curves? Okay, basically we need to know what the following question. Okay, so this is in the domain. So this is h in the domain of f. So in the domain here, the whole xy, I have these points, only the parabola. These points in the parabola. For example, if I take the points in the parabola corresponding to c equal to 0. Y equals x squared. All points in y equals x squared. These are points in the domain, and they are on the scale. The question is the following. What is the value of the function at these points? What is the value of this function at these points here? Okay. The answer C equal to 0. Okay. So the value هيكون C. So in any points in this parabola here, y equals x squared, the value of the function is 0. Okay. Any point in this parabola here, y equals x squared minus 1. The value of the function at any one of these points هتكون minus 1, C. The same thing here for any point in this parabola, y equals x squared plus 1. The value of the function at each point in this parabola هيكون C, which is h1. Okay, 1. Okay. This gives us level curves, gives us information about the image, really, the image of some point. Okay. So this is really this is the definition. Okay. So here again, just read the definition again. So the level curves of a function of two variables z equals f of x, y are the curves in the domain. So they are curves in the domain of f whose equations are given by this. So this is a curve, an equation of a curve, okay, where c is a constant. Okay. Now, if you take this level curve, any point in the level curve, f will take it to the constant c and z. So the value z, and just replace z with c. So the value f will take any point in the curve to the point C. Okay. So this is the level curves. Okay. Now, if it is not clear, just me again. Really, the idea is easy, but the terminology maybe it makes it not easy. Now, to clarify the definition, let's go to orientation. Okay, orientation. Math 001. Math 001. In Math 001, if you remember, for example, let me take y equals x cubed. Okay, x cubed. So this is the graph. Okay, this is the graph of y equals x cubed. Okay, so this is the domain, the axis of domain, and this is y, and this is h, the range. Okay, range. The range will be in the y-axis, and the domain will be in the x-axis. Okay. Usually when you have x, you can find y. This is the direct thing. Now we'll go backward. If you know y, how to find x. Okay. So for example, if I take 1 in the range, what are the values in the domain going to 1? Going to 1. If you know y, what are the values in the domain? Okay. Going to 1 or mapped to 1. Okay. How to find them? Well, if y equals 1, can you find which x is going to 1? Yes, just replace y with hx cubed equals 1, and then you solve to get hx equals 1. And this one here, 1 will go to 1. Okay. Yani, now take, what about which value is going to 2? This is h2. Okay. If y equals 2, what are the values in the domain going to y equals 2 or having the image 2? Okay. So this gives you the following. Okay, x cubed equals 2, and then you solve. So this is h cube root x equals cube root of 2. Okay. So if you know the range value, I can find the domain value going to the range value. Okay. If I know y, the range, I can find the domain values going to y. Okay. Yani the pre-image, the pre-image. This is for functions of one variable, and this is h y equals f of x. Okay. You can ask for any type of functions. Okay. In fact, this is h what level curves are. Okay. So notice here, yani, if you have a function of two variables, if take any value in the range, for example C, how to find the values or the points in the domain going to C? So C is the range value, so it is Z, the Z value. So how to find the points in the domain? Just replace Z with C. You get a curve here. Okay. In general, you get a curve. So you have the whole curve will go to C. The whole curve will go to C. Okay. So it is like the pre-image. So C is the range value. You just substitute, replace it with C. You get a curve. Any point in this curve, the function will take all these points to the value C, to the range value C. Okay. Now, why are they are curves? Because their equation are curves, equations of curve. F of x y c f of x y equals c. It is a curve, so it is good. Why it is good level? because the image will take it to the sea level, to the Z equals C, to the Cth floor or floor C. Okay. So here, for example, in our example, these are some level curves. Okay. These are some level curves. Okay. Now the first level curve here, y equals x equals plus 1. Y, the function f will take each point to the first floor, floor C equals 1. And the function will take any point on this curve, y equals x equal to the ground floor, c equal to 0, xy plane, z equal to 0. And the function will take any point on the third parabola, y equals x equals minus 1, to the basement or to underground floor, c equals minus 1. So each curve will go to a level, to a floor, will go to a floor, okay, first floor, second floor, and etc. Okay. So this is this is roughly speaking what is a level curve. So basically, you are finding a pre-image. If I know Z, what are the pre-image? What are the values in the domain going to Z? Okay. Our Z is always equals C, equals C. Okay. When you substitute, you get a curve. So this curve will go to the Cth floor. Okay. So this is for functions of 2 variables. Now, when you have functions of 3 variables, W equals of x, y, z. You do the same thing, but they are called level surfaces. Level surfaces. And it will be the level surfaces given by the exactly the same. So they are just of x, y, z equals a constant. C, the range value C. Okay. So we'll get H as surface and level as above level surface. F will take the level surface to C, to the Cth floor. Okay. The level curves, level surfaces are the same, except curves for functions of 2 variables, surfaces for functions of 3 variables. Okay. One example here. Describe the level surfaces of x, y, z equivalent x squared plus y squared plus z squared. Well, they are given the level. So the answer is the same, really. The level surfaces are given by the equation of x, y, z, of x, y, z equals C. C, a real number. Arbitrary. Well, what is f? You just substitute f هتكون ايش؟ ln of x squared plus y squared plus z squared equals C. Simplify, take the exponentiation of both sides هيكون x squared plus y squared plus z squared equals e power C. Okay. What is this? These are spheres. Center, the origin, and radius equals root e power C. But the level surfaces are spheres. Okay. We can't draw one level surface. If I choose C equal to 0, what do I get? I get x squared plus y squared plus z squared equals 1. So I get this level surface. Okay. The sphere x, y, and z. The unit sphere, so this is the unit sphere here. 1, 1, and 1. Okay. So this is H, C equal to 0. Okay. Question. What is the value of the function at any point on the sphere? Choose any point in the sphere. What is the value of the function at that point? هتكون C equal to 0. So C is the range value. Now we are giving you C. Find what is the pre-image. What is the value? What are the points in the domain? Usually the points will be H curves or surfaces. Okay. So this is H. What is the definition of a level curve or level surfaces? Okay. Okay. So let me. That's it.